Hi everyone, welcome back. Today we are diving into an exciting topic, software defined radio, or commonly known as SDR. Whether you are an electronics and communication engineering student or just curious about how wireless communication works, you are in the right place. Before we get into SDR, let's cover some essentials that set the stage for understanding radio communication. Imagine radio as an invisible highway for information. Radio is the technology that let us send and receive information wirelessly over long distances using electromagnetic waves. So we can say that it's the backbone of everything from AM and FM broadcasting to walkie-talkies and even wireless internet. Now let's talk about radio communication. At its core, radio communication is the process of transmitting and receiving signals using radio waves. Let's have a look how it works. A transmitter creates radio waves by converting your information into an electromagnetic signal. Then the receiver captures those waves and decodes them back into the original information. This process is critical for everyday services like broadcasting your favorite radio station, supporting aviation systems, and ensuring emergency services can stay connected. So, what exactly are radio waves? They are just a type of electromagnetic wave, a form of energy that travels through space. Unlike sounds, which needs a medium like air, radio waves can even travel through the vacuum of space. They are the reason you can stream music on your radio, use your cell phone, or even connect it to a Wi-Fi. Now let's zoom out a bit and look at the electromagnetic spectrum. So what exactly an electromagnetic spectrum means? It's a range that includes every type of electromagnetic wave, each with its own unique properties. So just have a look at some of the electromagnetic waves. First one we are discussing about radio waves. So these have the longest wavelength and the lowest frequencies. They are used in everything from AM, FM radio to TV broadcast and even Wi-Fi. The next one is microwaves. With shorter wavelength and higher frequencies, microwaves heat your food in oven and enable mobile phone communication. Another one is infrared. It's just a bit longer than visible light. Infrared is what makes your TV remote control works. Next one is visible light. So this is the small slice of the spectrum our eyes can detect, giving us all the colors we see in the world around us. Another one is ultraviolet rays, UV, commonly called as UV. So these waves are shorter and more energetic than visible light, which is why they can cause sunburn. They are also used in sterilization and tanning birds. Next one is X-rays. It's a common and familiar name. This is known for their higher energy and shorter wavelength. So X-rays are invaluable in the medical imaging area. And next one is the gamma rays, which is the shortest wavelength and the highest frequency. Gamma rays pack a lot of energy. They are often used in the radiation therapy for cancer treatments. So this is all about the electromagnetic spectrum and the different types of electromagnetic waves. Let's now break down what goes on inside a traditional radio. You are familiar with the radio, you use the radio. So what are the things inside a traditional radio? So first we start with an antenna. So this is the starting point where the radio waves are captured from the air and it is converted into an electrical signals. And the next one is the tuner. Think of the tuner as your channel selector. It picks out the specific frequency you want to listen to while filtering out the rest. When you're listening to an FM station or a FM radio, if you want to jump to another station, you will tune that. So that's the purpose of the tuner. The next one is amplifier. Since the signals coming in a pretty weak, so the amplifier boosts them to a level where they can be processed further. So the further process to be done, we should amplify that signal. The next one is the detector or the demodulator. This component extracts the actual audio or the data from the radio wave. Whether it's AM or FM, the demodulator retrieves the content that was transmitted. And the next block is audio processor. To make sure the sound is clear and pleasant, the audio processor tweaks the signal, adjusting its tone, volume, and overall quality. Next is audio amplifier. So once the signal is processed, the audio signal gets another boost here. So ensure that it's strong enough to drive to the speaker. And the final stage is the speaker. So the speaker converts the electrical signal back into the sound waves and letting you hear the broadcast. Okay. And one more thing you have to add on this, that's the power supply. And of course, none of this would work without power. So whether it's a batteries or an external source. So from capturing invisible radio waves with an antenna to transform them into a sound we hear through a speaker, every component plays a crucial role in this seamless operation of a radio. So this is how a traditional radio works. Now that we have covered the basics of radio and how traditional radio communication works. Okay. So let's dive a bit deeper into its real world applications. Okay. So traditional radio communication have been a cornerstone of broadcasting for decades. It's been widely used to deliver music, news, and vital information to broad audiences across vast areas. Think about its AM and FM radio stations that have been a heartbeat of communities across the globe or around the globe. AM, with its extensive coverage, has allowed talk radios and news broadcasts to reach listeners far and wide, especially during the night when the atmospheric conditions help extend its range. On the other hand, FM is your go-to for high-fidelity audio, making it a choice for music lovers, even though its range might be a little shorter. Let's break down the two primary modulation techniques, that is AM and FM. So first we are talking about AM, amplitude modulation. So how it works? In AM, the amplitude or strength of the carrier wave is varied in direct proportion to the audio signal. So it has some advantages. The first one is the simplicity and the cost effectiveness. AM is relatively simple to implement. So it is simple to implement, that means it's a cost effective. So the another advantage of it is long range. So it can travel a long distances, especially in night, it can travel a long distances. And also it have an effective bandwidth usage. That means it occupies a less bandwidth, letting more stations share the spectrum. So that's a useful thing. And the efficient bandwidth usage reduces the cost. So these are some of the advantages of the AM, amplitude modulation. So if you're talking about its negatives or its cons, there are interferences. So AM signals can easily pick up noise from electrical sources and atmospherical disturbances. So that's one of the drawback of this amplitude modulation. And when you talk about the quality, the audio quality, they often suffer from a lower audio quality. So with issues like hissing and fading, etc. And the next one is the limited frequency response. So the frequency response that can affect the clarity, and particularly at higher frequencies that can affect the clarity. So that's one of the another drawback of the AM. We move to frequency modulation, that is FM. So FM is a very common term when you talk about a radio. FM varies the frequency of the carrier wave based on the audio signals we are giving. It also has some pros and cons. So first we talk about its pros. It have a superior audio quality. You know that FM is renowned for its clear and high quality sound. It is perfect for the music listeners. And the next one is resistance to interference. So it's less prone to noise, so ensuring a more consistent listening experience. So that's also an advantage. So next one is the wide frequency response. So this allows for better transmission of high frequency audio. So these are the pros of frequency modulation. Along with that, we can say its cons are the larger bandwidth requirement. So it required some larger bandwidth, and FM signals uses more bandwidth, which can limit the number of stations. So there is a limit for the number of stations also. So the broadcast range also a little bit shorter. FM signal typically don't travel as far as AM. When you compare to AM with FM, the FM signals typically don't travel as far. So these are the cons of FM. So we discussed about FM and AM. So you have some doubt that why we use AM and FM, right? It all comes down to the application. So AM is often the choice for talk radio and news due to the long range capabilities and its simplicity, while FM is favored for the music and the high quality over the audio broadcast. So beyond this, let's quickly look at some of the other radio communication techniques that you may find interesting. Okay, so AM radio, that is perfect for straightforwarding broadcasting. FM radio, that is ideal for delivering crystal clear audio. Those things are we already discussed. So the other one is the two-way radio. Maybe you heard about walkie-talkies. Okay, which allow a direct and immediate communication between the users. So the another application is the two-way radio. Next one is the cellular communication. So we uses the networks of cell towers to manage mobile communication, combining frequency and time division techniques. Okay. So and the other one is satellite communication. So it relies on orbiting satellites to relay signals across continent and even around the globe. Okay. So each of these methods plays a critical role in ensuring that our messages, music, and information travel smoothly from one point to another. So each one have its own uniqueness and its own advantages and trade-offs. Okay, stay with us. We transition into exploring how software-defined radio is revolutionizing this landscape by shifting many of these functions from hardware to software. So creating a more flexible and dynamic approach to the radio communication. So in the next part of this video, we are going to explore how SDR or software-defined radio takes the traditional concepts and transform them with the software controls. So it will opening up the whole new world of possibilities in the radio communication. So stay with us. We transition into the exploring how software defined radio is revolutionizing the landscape by shifting many of these functions from hardware to software, creating a more flexible and dynamic approach to the radio systems.